You're parked on a hill. You put your car in park, or maybe in gear if it's a stick shift. Then you pull the emergency brake. You might think you're doing everything right. You might think, well, the parking brake is just a backup for emergencies or maybe for a really steep hill, but I'm here to tell you that if you are using your parking brake after you put the car in park, you are making one of the biggest mistakes you can make for your transmission and your entire drivetrain. You are causing stress, wear, and damage that cost hundreds, maybe thousands of dollars to fix down the line. The parking brake isn't some extra lever. It's the single most misunderstood and misused part of your car. And never use the emergency brake like this. You are grinding away the life of your most expensive components and you don't even know it. I've worked on cars for years, and I've seen this mistake made by almost everyone, even people who think they know their cars inside and out. It's a simple habit, but it leads to a huge problem. People call it the emergency brake, which makes you think it's only for emergencies. But its real name is the parking brake, and if you're not using it every single time you park, and more importantly, using it in the right order, you are putting massive strain on one tiny, critical piece of metal inside your gearbox called the parking pawl. This video is going to dive deep into exactly what that little piece of metal is, why it's so important, and why using your parking brake in the wrong order can snap it, wreck your transmission, and leave you stranded. This isn't just about saving a few bucks, it's about understanding a fundamental, critical process that keeps your car healthy and your wallet closed. We're going to cover exactly what order to use the brake in, whether you have an automatic or a stick shift, and why the whole process changes if you're on a flat road versus a steep hill. The main problem is a lack of understanding about what actually stops your car from rolling away when you park. In an automatic transmission car, when you slide the shifter into P, park, you are not activating a massive locking mechanism. You are doing something surprisingly small. You are telling the transmission to engage the parking pawl. Picture the parking pawl like this. It's a tiny metal finger, maybe the size of your actual finger. When you put the car in park, that metal finger slips into a matching slot on a rotating gear inside the transmission, called the output shaft gear. It's basically a small stopgap. When that pawl is locked in place, the output shaft can't spin, and therefore your wheels can't roll. The challenge is that when you park on any sort of slope, even a slight one you can barely feel, the entire weight of your car, which is thousands of pounds, is resting on that tiny metal finger. You put the car in P. The car rolls an inch or two until the pawl slots in, and suddenly 2 tons of force is crushing that little metal part. When you go to leave and you try to pull the shifter out of P, that tiny metal finger is still under that crushing pressure. That's why you hear that horrible clunk sound and feel a massive jerk when you shift out of park on a hill. You are literally pulling the parking pawl out of its socket while it's holding the full weight of the car. If you do this enough, 2 things happen. You damage the pawl itself and you severely stress the entire shift linkage and transmission mounts. Eventually the pawl can fail and then your car is rolling. The solution is simple, but it goes against the common habit. The parking brake needs to take the weight before the parking pawl ever gets a chance. Exploration development, the science of weight transfer. To really understand why the order matters, we need to trace the path of the car's weight when it's parked. The weight path of an incorrect park, automatic. Stop. You hit the brakes and stop the car. Park first, you immediately shift to P. The parking pawl engages, but it doesn't always engage instantly. The pawl is usually sprung, so it waits for the gear slot to line up. Release foot brake. You lift your foot off the brake pedal. The drop. The car rolls forward or backward a few inches until the pawl slams into the next available slot on the output shaft gear. That clunk sound you hear? That's the entire weight of the car violently slamming onto that little metal finger. The parking pawl. Now all 4,000 pounds of car weight is concentrated on that tiny single point. The force is immense. Every time you leave the car like this, you are effectively using the transmission itself as a weight-bearing stop. Transmissions are meant to transfer power, not to act as a permanent brake.
The weight path of the correct park, automatic and manual.
The secret is to use the parking brake to absorb the weight before the transmission ever sees the load. Stop, you hit the brakes and stop the car completely. Neutral. Before you do anything else, shift the car into neutral, N if it's an automatic, or leave the clutch in and put it in neutral if it's a manual. The car is now held only by your foot on the main service brake, the pedal. Engage parking brake. While your foot is still firmly on the brake pedal, pull the parking brake lever all the way up, or push the electric parking brake button. Transfer weight. This is the most critical step. With the parking brake fully engaged and your foot still on the main brake pedal, gently and slowly release the main foot brake. The parking brake now takes the car's weight. The car might rock a tiny bit, but the parking brake mechanism, the drums or calipers at the rear wheels, absorbs the weight. Engage park gear. Now and only now you shift your automatic transmission into P, park, or if it's a manual you put it into first or reverse gear, depending on the hill direction. Since the parking brake is already holding the entire car's weight, the parking pawl in the transmission slips into its slot without any weight or stress on it. It's just there as a redundant backup safety measure, not the primary stopping force. When you come back and get in the car, you do the reverse. Start the engine, shift out of P, then release the parking brake. The transition will be silent and smooth, which is the sound of an undamaged transmission. Exploration development. Where is the damage happening? People often think the damage is only about that loud clunk when they shift out of park. But the damage is far deeper and more expensive than just that. It's happening in three main areas: the transmission, the parking pawl itself, and the brake cables. 1. The transmission mounts and linkages. That violent clunk sound when you pull the shifter out of park is not just noise. It is the entire force of the car's weight being suddenly released, causing the whole drivetrain to jerk violently. This places huge sudden stress on the transmission mounts, the rubber parts that hold the heavy transmission bolted to the car's chassis. These mounts are designed to handle the gradual twisting forces of driving, not massive, sudden, violent jerks when you shift from park. Over time, these mounts crack, tear, or completely fail. If a transmission mount fails, the engine and transmission can move excessively. This leads to loud vibrations, misalignment of the drive shaft, and it puts enormous stress on the shift linkage, the mechanical connection between your gear selector and the transmission. Repairing transmission mounts is a labor-intensive and expensive job, sometimes costing hundreds of dollars just in parts and time. 2. The parking pawl itself. The tiny metal parking pawl inside the transmission is made of tough steel, but it's not meant to hold thousands of pounds of static load daily. Repeated slamming of the car's weight onto this pawl leads to pawl deforming. The edges of the pawl and the gear slot get rounded off and deformed. This makes the pawl less secure and increases the chance of it slipping or failing completely. Stress fractures. Constant high impact can lead to microscopic stress fractures in the metal. If the pawl breaks, it often sends metal fragments through the transmission fluid, causing catastrophic damage to other expensive moving parts. This is a nightmare scenario that requires an entire transmission overhaul or replacement. 3. Parking brake cable failure, the other damage. If you never use your parking brake, which is a common mistake for drivers who fear forgetting to release it, you face a different kind of damage. The parking brake system relies on steel cables that run from the lever or pedal to the rear brake mechanisms, calipers or drums. If these cables are left static and unused for years, they rust. Water and dirt get into the cable sheath and they seize up. When you finally do need the parking brake, maybe you're on a huge hill or your main brakes fail, and you yank the handle, the seized cable can snap. Or more commonly, if you finally engage a seized brake, it can get stuck on, overheating your brakes until they fail completely, or even catch fire. Using the parking brake correctly every single time keeps the cables and the brake mechanism exercised, lubricated, and ready to work safely when you need them most. It's the mechanical equivalent of stretching. The neutral, then parking brake, then park routine is the golden rule, but it changes slightly for different setups. Modern cars often have an electronic parking brake, EPB, which is just a button instead of a lever. The rule remains exactly the same, but it's even easier to follow. Stop, foot on the main brake. Neutral, shift to N, engage EPB. Push the button. The electric motors clamp the rear calipers, instantly absorbing the weight. Park, shift to P, done. In fact, some smart modern cars are programmed to automatically engage the EPB when you shift into P if they sense an incline, but you should never rely on that. Always do the manual sequence to guarantee the EPB takes the load first. For a manual transmission, the process is slightly different, but the goal is the same. Let the parking brake take the load. Stop. Foot on the clutch and foot on the brake. Shift to neutral, parking brake. Pull the parking brake lever up firmly. Release foot brake. Gently lift your foot off the main brake pedal. The car's weight is now resting on the parking brake. Engage gear. As a secondary safety measure, you must put the car into gear. Use first gear if the car is facing downhill, or reverse gear if the car is facing uphill. This uses the engine's compression to resist movement, making it a third layer of safety after the parking brake and the main transmission itself. Never rely solely on putting a manual car in gear, especially on a steep hill. The compression can eventually give way, or if the car is bumped, the gear might not hold. The parking brake is the primary mechanical lock. If you are parking on a truly steep slope, you need one final safety measure to protect against both parking pall and parking brake failure: turning your wheels. Facing downhill, turn your front wheels toward the curb. If the brakes fail, the car will roll gently into the curb and stop harmlessly. Facing uphill, turn your front wheels away from the curb. If the brakes fail, the car will roll backward until the rear of the tire bumps against the curb. This wheel turning trick is a legal requirement in many places, and it acts as the final last resort mechanical stop. If you combine the correct parking sequence, neutral, parking brake, park, torque, gear, with turning the wheels, you have maximized safety and minimized damage to your car. We've talked a lot about microscopic damage and stress, but let's talk about the payoff for fixing this simple bad habit. It comes down to two things: a big number on an invoice and a beautiful sound or lack thereof. A transmission replacement is one of the most expensive repairs your car can ever need, often costing between $3,000 and $7,000, depending on the car. While using the parking pall incorrectly won't instantly destroy your transmission, the cumulative effect of thousands of clunks stresses every moving part, every mount, and every seal. You are essentially adding hundreds of dollars worth of wear and tear every single year to the most expensive system on your car. But let's be more specific. The repair for a broken parking pall often requires dropping the transmission, taking the whole thing apart, and replacing the pall and its corresponding gear. This is highly skilled, expensive labor. You are looking at a bill of easily over $2,500 just to fix that one tiny metal finger. The real payoff is the silence. When you shift your car out of park using the correct sequence, there is no noise. There is no violent jerk. There is no sound of 2 tons of steel unsticking from a tiny metal finger. The car glides silently out of park because the weight was already being held safely by the mechanical parking brake. That silence is the sound of a happy transmission, healthy mounts, and a parking pall that is just resting, ready to act as a light backup. This is the single simplest free maintenance step you can take to dramatically increase the lifespan of your vehicle's most complex and costly component. It's a fundamental shift in how you think about parking, moving it from a simple shifter into P operation to a deliberate 2-step process that respects the physics and mechanics of your vehicle. The payoff is thousands of dollars you never have to spend on transmission repairs. This simple bad habit, putting your car in park before pulling the parking brake, is destroying the most expensive parts of your car, one small clunk at a time. The cumulative stress on the tiny parking pall and the transmission mounts adds up quickly, leading to costly failures and premature wear. Remember the golden rule: whether you have an automatic or a manual, and whether you have a lever or a button. Neutral, parking brake, then park, gear. Use the parking brake to absorb the weight of the car first, and then let the transmission's park function act as the non-stressed safety backup it was designed to be. Use the parking brake every single time you park, even on a flat road, to keep its cables and components healthy and ready for a real emergency. This small change in routine is the single most effective way to ensure your transmission lives a long, quiet, and happy life.